All right, now we're going to start looking at sedimentary rocks. Sedimentary rocks are formed from one of these three. It's just accumulation of different types of sediments, some organic matter, or chemical precipitates. If you remember back to the mineral unit or topic, that the chemical precipitates could be like salt from salt water that is evaporated off, or from caves, all the stalactites and stalagmites. So how they form, and these little gifts are amazing, just to let you know. The first thing, most sedimentary rocks are made up of solid sediments that have been weathered down or broken off of other rocks. And once those weathered sediments are broken off, they tend to be transported or eroded away by one of the three things, either water, wind, or ice. Eventually, they settle somewhere or deposit somewhere in a different location, either in the water or on land. And after that happens, it starts to build and build and build and build and build and build and accumulate. And because you have so much building on each other, it starts to create pressure, and it starts to smoosh it or compact it down. And then it starts to get cemented together. Usually this is a natural process by water mixing with some type of mineral in the water, and it cements everything together. So this is one way to show it. So layers of sediments are deposited. You have silt, sand, clay, and you get more and more and more silt on top, usually underwater, and it starts to push and push and push and push and push. And as it pushes, sand, clay, silt, and clay, those turn into sandstone, shale, siltstone, and shale. All right, so there are three types of sedimentary rocks. You can find it right here, page 7 at the top, says Scheme for Sedimentary Rock Identification. So the first type we're going to look at is called clastic. These are formed from inorganic rock particles or sediments that are pressed together and or cemented together. So compaction. Sediments are pressed together by the weight of overlying rocks, just like you saw before. And if you're unsure how exactly sedimentary rocks are formed, if you look on page 6 at the top, you have sediments right here that go to deposition and burial, then to compaction and cementation, then finally over here to sedimentary rocks. So first they're compacted together. They're smushed down. Cemented, they're then glued together, and you'll see all this open space, this pore space. We'll get to that in the next unit. But this pore space, this open space, is filled in with water that has minerals in it. And it forms a cement in between the smushed bits, because you'll see there's pore space still there. And so this happens after deposition. So you'll see the loose sediments, the compaction and pressure being put on it. Natural sediments dissolved in water start to form that cement. All right, then in these clastic, they kind of form like a biggest to smallest type thing. And you'll see it again on page 7 at the top. Sorry, this side right there. And you'll see it says clastic over here, or fragmental. So it's going to go by grain size. So the first part, you have boulders, cobbles, pebbles, and then you have sand, silt, and clay. How do you know what's what? Well, you're looking at the different particle sizes or the different composition, what's in there. So we're looking at the biggest one with the boulders and the cobbles and the pebbles that are rounded. It's not like the best, but you can kind of see where I've got like pebble pudding going on. Like lots of pebbles put together. These are called conglomerate. And typically you find them in rivers and streams and so forth. The next one, you have angular fragments. This one's harder to see, but you can see the angles on it. Typically this is found in like till that has fallen off from mountainsides. It's angular. It looks like it's gonna break you. It's called breccia. That's how I remember it, because it looks like it's gonna break you. The next one you have, this one is the most identifiable, the one that you know the most probably by looking in like the Grand Canyon or down in Arizona, how it looks reddish. So you have this reddish layered, and you can see the layers over here, how it's kind of layered up, different colored red. This is sandstone. It comes from sand. And these next ones are really easy. These two. So sand makes sandstone. The next is silt. Silt is much smaller than sand. You kind of need a magnifying glass to see these particle sizes. But this is called siltstone. It can be anywhere from the darker gray to the lighter, whiter, almost chalky looking. And that, which makes siltstone. So silt makes siltstone. And then last but not least, this one is the most interesting. It's compact, may split easy. It is the finest. And you'll notice I got lots of stuff in this one. This one is called shale. I know this is shall not be shiny. And this is the one that you typically find. You see all these bumps on this one? These bumps or little different things you find in it, those are fossils. This is the one you're going to find lots of fossils in, that shale. Okay, so those are all the classic type. Now we have the chemical type. These chemical types are called non-clastic or crystalline, right here. They form from dissolved minerals that settle out of the precipitates. So these are the settling out, like at the caves. These are the left behind by water or evaporates. And we aren't really going to get to see those, although you've already seen one. The halite is actually rock salt. And you also saw gypsum. That's rock gypsum. Those both are crystalline or non-classic or chemical. Just like I said before, you have these sediments that are smushed together. The salt smushed together makes rock salt or halite. And then you have this that forms this, which is rock gypsum. And this we didn't get to see, although I did show some dolostone from dolomite. All right, our third and last one. This is kind of like a combination of crystalline and bioclastic. This is formed from previously living things, like plants or animal remains. The first we're going to see is the bioclastic. So I know it says limestone twice, but there is a difference between the two. The first type, really hard to see this one. It kind of looks like oatmeal, like this. That is called a bioclastic limestone. This one right here is also kind of like a bioclast, but it's formed and it looks a little bit more like that crystalline. This one is definitely a mixture of both. This one is the mixture of both bioclastic and crystalline. That one is the first type. This type has big shells. You can legitimately see the shells, and this is formed or cemented by the calcite that you find in it. And then this one is dissolved shell fragments. You'll see it really is more dissolved shell fragments and a little bit of like holy parts left by shells. And again, it is cemented together by calcite. And then last but not least, we have this one. You see a little bit of layers. It's a little shiny. This is called bituminous coal. This is formed from compacted plant remains, like what you would find in a bog, where the plants would just die and fall over and fall onto each other and just pile and pile and pile and pile to form coal. So this is the formation of what I just showed you, the bituminous. So the first thing you get is peat, and you can still see some of the plant remains. So it's in a not necessarily a bog, but where there's no free-flowing water. So when the plants die, they fall on top of each other, and they don't exactly decomp. They just keep piling up. And first you get is peat, like peat moss. And as it keeps getting pushed down, so there's that layer of peat moss or peat. And then it keeps getting pressed down and you get this called lignite or brown coal. And then as you keep pushing and pushing, you get bituminous, 85% carbon, soft coal. Right here, you saw that. It's a little tiny bit shiny, not a whole bunch. And then, which we're going to see next, is anthracite coal. So I keep pushing and pushing and pushing. This is the coal that we burn. But if you keep pushing that one and you keep pressure and heat on it, that anthracite turns into diamonds. So, and it all happens over time. All right, let's look at my lovely little rocks and let's see if we can identify them. So rock gypsum. That one is probably going to be number 4. It's more milky, more powdery looking. Then we have rock salt. That's got to be number 1. Breccia, angular. Angular is number 2. Conglomerate, pebble pudding. That's number 7. Limestone. That one's going to be this one. It looks kind of like granola. Don't eat it. The next one is shell. Shall not be shiny. You find fossils in it. That one's got to be number 8. Then we have sandstone. Looks like sand, usually orangish. That's going to be 6. And last but not least, we have number 3, bituminous coal. All right, so that's it for the rest of the notes. If you have any questions, please don't hesitate to ask, and I hope you have a nice day.